All right, welcome to today's analysis. We are tackling what is honestly the most critical and definitely the most chaotic frontier in AI engineering right now. We're calling this the everything blueprint for LLM evaluations. Look, if you're building AI, you already know the deal. Taming the unpredictable, wild nature of large language models, it's a massive headache. So today, we're going to transform all that chaos into a highly structured, end-to-end masterclass. We'll explore how you can rigorously evaluate both the foundational models and those complex applications you're building around them. Okay, let's just dive right into this. So here's our roadmap for this everything blueprint. We're going to start with the core of LLM evals, then split things into model versus application testing. After that, we'll navigate benchmarks and leaderboards, dive deep into the offline evaluation workflow, look at online evals and production monitoring, and finally tie the whole shebang together with the continuous improvement loop. Kicking things off with Section 1, the core of LLM evals, where we talk about moving way beyond basic software testing. Testing in AI, it is fundamentally different and honestly way more complex than traditional software testing. I mean, if you just write basic unit tests and expect exact string matches, you are going to fail for sure. So, what are LLM evals? They are systematic, repeatable tests used to judge an LLM or an LLM-powered system against very clear criteria. I really want you to focus on those words systematic and repeatable, because without a defined rubric, you aren't really doing engineering, right? You're kind of just blindly chatting with an AI and crossing your fingers. To actually evaluate, you absolutely need that rubric and a repeatable process. Moving on to Section 2, model versus application testing, basically the two hemispheres of AI testing. To truly evaluate AI and actually master this everything blueprint, we need to divide the universe into two distinct hemispheres. It helps to think about it like hardware. Model Fs, that's about testing the foundational LLM itself. It's exactly like stress testing a raw CPU or GPU, which is exactly what companies like OpenAI or Google do when they run their tests. Application apps, on the other hand, are what you do as an AI engineer. You're testing the complete software system. Think of it like testing the fully assembled laptop. You're making sure the screen, the battery, and all the software play perfectly nice with that CPU. That brings us to Section 3, benchmarks and leaderboards, and how frontline models are actually graded. Now, before you can build a killer application, you got to select the right foundational brain for it, right? And to do that, we rely on industry standard tests. Just look at the chronological evolution here. Back in 2020, we had MMLU, which tested a model's breadth of knowledge across a bunch of subjects. Then by 2021, everyone realized, wait, these models hallucinate. So truthful QA was introduced to test reliability. But here is the wild part. AI evolved so incredibly fast that MMLU actually saturated. Models started hitting a 90% human baseline. The test literally became obsolete for distinguishing top-tier models. So flash forward to 2024, and researchers had to scramble to create much, much harder exams, like GPQA and HLE, which stands for Humanity's Last Exam, just to test expert-level depth. But hey, a quick, very serious warning for all you focus builders out there. Beware of benchmark contamination. You absolutely cannot blindly trust benchmark scores anymore. Why? Because these tests are open source and floating around on the internet, which means AI models often accidentally memorize the test questions from their training data over time. It is literally exactly like a student getting the answer key before the final exam. Totally skews the results. So to navigate this pretty chaotic space, we turn to leaderboards. And these generally fall into four categories. First, you've got benchmark-specific boards, which rank based on a single test, like the HLE leaderboard. They're a bit narrow. Then you have multi-benchmark boards, like LiveBench or Artificial Analysis, which aggregate multiple capabilities. Third, we have human preference boards, like the LMSES Chatbot Arena, where users blind vote on responses. And finally, application-specific boards that focus on one domain, like the Berkeley Function Calling Leaderboard. Now, if you're an engineer, multi-benchmark and human preference boards, those are generally going to be your most useful tools for filtering down candidate models. All right, Section 4, the offline evaluation workflow. This is all about pre-deployment preparation. So we are now shifting entirely into that second hemisphere we talked about, application evals. The big question is, how do we rigorously test our custom software before it ever even reaches a real user? Well, here is your step-by-step master workflow. Step 1, define your task and target metric. Step 2, build a golden dataset. Step 3, define your evaluation method. And Step 4, run, analyze, and iterate. Seriously, I want you to burn these 4 steps into your memory. This is the repeatable loop you are going to use for literally everything, from the simplest chatbots to the most complex multi-agent systems. Let's actually see how this builds out with a concrete business example. Imagine we're building an AI application for Zomato to route their customer support emails. First up, we define the task, right? Classifying incoming emails. Our target metric here is overall accuracy. Then comes the absolutely crucial part. We build our golden data set. We take, say, 50 to 500 past emails and manually label them as billing, technical, or general. This data set right here, this becomes our absolute, unshakable source of truth. Now, for a classification task like that, checking accuracy is pretty easy. You just match the labels. But let me pose a question to you. What if your AI outputs a long, semantic paragraph? Let's say it's a custom, personalized response to a user. How on earth do we evaluate its correctness? You can't just write a simple Python script to check if 2 paragraphs mean the exact same thing. And paying humans to manually read and grade thousands of test responses? Yeah, that is way too expensive and slow. Well, the brilliant industry solution to this bottleneck is what we call LLM as a judge. It's exactly what it sounds like. You literally use a smarter, larger model, like a GPT-4, to act as a teacher, basically grading the homework of your application's smaller model. You give this judge a very strict, predefined rubric, and it programmatically evaluates the outputs based on that. It's a total game changer. It brings the nuance and intelligence of human grading, but at the blazing speed and low cost of code. Moving on to Section 5, Online Evals and Production Monitoring, or, as I like to call it, surviving live traffic. Okay, so once your offline metrics look great, you hit deploy. Awesome. But the work definitely doesn't stop there. The dichotomy between offline and online is super stark. Look at it this way. Offline evals happen pre-deployment. You have your fixed golden data set and you are measuring strict correctness. Online evals, however, happen post-deployment. You are out there in the wild dealing with live traffic. And guess what? You don't have an answer key for what the user just asked. Because of that, you aren't measuring correctness anymore. You are measuring normalcy. You're looking for weird drifts in the data or unexpected behaviors. To actually monitor this normalcy, you follow a specific architecture. First is logging. You absolutely must capture a structured record, what we call a trace, of every single conversation. Tools like Langsmith are fantastic for this. Second is reference-free eval. This is where you use your LLM as a judge on a sampled subset of this live traffic to flag issues like toxicity or hallucination, and you do it without needing a golden answer key. And third is monitoring. You track those score distributions over time so you can detect any drift the moment it happens. Which brings us to our final section, Section 6, the continuous improvement loop, proving that evaluation is never really finished. Because the hard truth is, evaluation is never truly finished. We are going to zoom back out now and connect both of our hemispheres using the ultimate secret to reliable AI applications, the infinite cycle. Let's say your online monitoring flags a production failure. Maybe a user's highly technical email was wrongly routed to the billing department. As the AI engineer, you jump in and extract that specific trace. You then take that failed example and inject it straight back into your offline golden dataset. Then, you tweak your system, reevaluate it offline to ensure it passes the new test, and redeploy, boom. I absolutely love this quote because it perfectly cements the complementary relationship we've been talking about all day. Offline evals check if your application works correctly. Online evals check if it runs normally. You simply cannot have one without the other. They are 2 halves of the exact same engine. This self-improving loop? This is the core takeaway of this entire everything blueprint. Today's live production failures literally become tomorrow's offline golden dataset. This continuous loop is exactly what separates the amateur chatbot wrappers from professional, bulletproof AI engineering. Which leaves us with this final thought. Your evaluation pipeline shouldn't just be some static checklist you tick off. It's a living organism. When you embrace the everything blueprint, bridging that rigorous offline testing with constant online monitoring, you create something incredible. So the question is, are you ready to build an AI system that learns from its own mistakes forever? Thank you so much for joining me in this analysis, and I really hope this empowers you to go out and build smarter, safer AI.